right, guys, so we are going to do number 3, which is dy dx equals 2x over y squared. All right, and my initial condition is y of 0 equals 3. So right now I want to separate the variables, so I'm going to cross multiply. So I get y squared dy equals 2x dx. I'm going to find the antideriv, aka integrate both sides. So I'm going to add 1 to the exponent, divide by the new exponent, equals add 1 to the exponent, divide by the new exponent, and plus c. I'm going to plug in my initial condition, so I get 1/3, 3 to the third equals 0 squared plus c. So we're going to get c equals 3 to the third is 27. 27 times 1/3 is 9. So we get c equals 9. So now we have 1/3 y to the third equals x squared plus 9. I want to solve for y, so I'm going to multiply everything by 3. So y to the third equals 3x squared plus 27. And then I'm going to take the cube root to get the y by itself, cube root, and I get y equals the cube root of 3x squared plus 27. I could have also raised both sides to the 1/3 because that's what the cube root means, but as long as you get that y by itself, it could be the cube root or 3x squared plus 27 to the 1/3. All right. Let's try the next one, number 4. Ooh, this is a doozy. All right, so we got number 4 is dy dx equals, and it's y over 2x. There's a little bit of a razzle-dazzle going on in this work, let me just tell you. So we get y of 2 equals 1. All right, so we're going to separate the variables. If I multiply by dx, the x is on the denominator here, so I'm going to multiply by dx, and then I'm going to have to divide by the y to bring it over to this side. I'm going to keep this 2 over with the x on this side, so it's going to be 1 over 2x dx equals 1 over y dy. All right, so I'm going to integrate both sides, aka find the antideriv. So this side is going to be ln, absolute value of y, equals, all right, now this has a 1/2 with that x. So this 1/2 can stay out in front, and then the 1 over x is ln of x, absolute value of x, plus c. Okay, get ready for a little bit of razzle-dazzle here. Here's where it comes. Now, I have a coefficient in front of that ln. Now, some of our rules of logs say that if I have this out in front, I can relocate it using the properties of logs to the exponent. So I'm going to go ahead and do that. ln, absolute value of y, equals ln absolute value of x to the 1/2. Ooh, plus c. All right, so then I don't know what ln of 2 to the 1/2 is. I do know what ln of 1 is, but I'm going to get the y by itself first. So I'm going to e both sides, and then it's going to be y equals, now I have an e to the plus c, that's going to be a big old c out in front. And then this e and ln are going to actually cancel each other out, and I get x to the 1/2. Now I can plug in my initial value, which is 1 equals c times 2 to the 1/2. All right, so that's going to be 1 equals c times the square root of 2, because anything raised to the 1/2, that's the square root. I'm going to divide both sides by the square root of 2, so c is equal to 1 over radical 2. So my final answer is going to be y equals 1 over radical 2 times x to the 1/2. So that one was super tricky, but I wanted to just kind of show you that little trick of if you have a coefficient out in front of the log, the properties of log say that you can move it back to the exponent. So that's like a little throwback there to Algebra 2 and pre-calc. All right, take a little minute and digest that.